Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, everyone, and welcome to another engaging session of the ISA Oman Knowledge Connect series. Today, we are privileged to host a distinguished professional who bring deep industrial experience and strategic insight into the world of operational technology security. It's my great pleasure to introduce our speaker, Mr. Naveen Menon. Mr. Naveen Menon is highly experienced cybersecurity and OT security professional with a strong background in industrial automation, critical infrastructure production, and international security standards. Throughout his work across complex industrial environment, he has played a key role in helping organizations strengthen their security posture beyond the traditional IT boundaries. Today, Mr. Naveen will be presenting on powerful and highly relevant topic beyond compliance, transforming OT security through the ISA IEC 62443 standard. This session will explore how organizations can move beyond treating standards as checklist exercises and instead use ISA IEC 62443 as true framework for building resilience, secure, and sustainable industrial environment. We're truly excited to benefit from his practical insight, real-world experience, and strategic perspective on OT cybersecurity. Please join me in welcoming Mr. Naveen Menon. Welcome on board, Naveen. Naveen? It looked like Mr. Naveen is having an issue. So Naveen is really having an extensive experience in terms of OT cybersecurity. So apologies for our audiences. It looks like we're having an issue in the connection, and I think Naveen will just join. Yep. Hi Naveen, welcome back.
Thank you. Thank you for giving me the opportunity. It's a pleasure to be here and discuss on this esteemed platform.
Thank you. So, Naveen, let us start with this question. With the increasing convergence of IT and OT and the rising number of incidents and cyber incidents targeting industrial environments, do you think most organizations today are truly securing their OT systems, or they are just aiming for bare minimum of compliance?
They are trying to be compliant, they are trying to secure their systems, but are they? Is the question that we'll try and look into in today's session. We'll try and understand what is compliance, we'll try and understand what is that security that we are talking about, and we'll see how they mix together and how we can secure the environment.
Super. So that's definitely
Thank you.
require organization to be beyond compliance. So without further delay, let's jump to your presentation and learn more. The stage is yours.
Thank you so much, Nasir.
I'm just facing issue, changing to the next. Can you share your screen?
Yes, I just did that. Yeah.
Okay. Minute. So let me just remove.
Thank you.
Okay, go ahead.
Thank you, and I welcome you all to this session and for taking the time out of your precious time to attend to this session on OT security through ISA IEC 62443. Um, I'm Naveen Menon. I'm a delivery manager, cybersecurity, OT cybersecurity, about 21 years of experience. I've been in Oman for about 8 years and working with Tove Redland. We provide OT cybersecurity services to our companies. I have been certified in these standards uh, for 62443. So the first thing that comes to mind when we are talking about cybersecurity is compliance, right? Because most of the pressure is because we need to be compliant, we need to be meet the regulations which are required by the regulator and the companies and the standards and so on and so forth. But is it really security? Can we say that if we are compliant, we are secure? There's an image uh, in this slide which shows a particular security measure which has been implemented, which is a road barricade. Actually, it's a gate. But if you see clear, if you see, you can see that on both road, there have been people who have been bypassing this security compliance. So compliance is there, but there is no security, right? So complying to a requirement doesn't necessarily mean that we are actually compliant to the actual intent of the requirement. So what is required is that we can be secure by actually meeting the intention of that requirement which is therein. So therein comes your various industrial standards, so and so on and so forth. So as we go on, the first thing that we need to understand in this whole thing is OT, which most of the people know. We have 5 levels in any organization, as has been defined in the Purdue model. So it starts from the level 0 and goes up to level 5, which is your enterprise zone. So mostly the SCADA and other central control systems will be at level 3, your demilitarized zone will be at level 3.5, and your business planning will be at level 4. The local controls being at level 2, and the basic controls devices being at level 1. So if you see in this slide, we can see that the availability factor, as we go from IT to OT, is going on increasing. And as we go from OT to IT, the availability is not that critical there. It's the RTO is in milliseconds in OT, whereas in maybe an enterprise, maybe emails are not working. Maybe it's fine if it's not there for days even, right? So safety wise also, as we go down, as we go up the ladder, everything changes accordingly. So the very nature of IT and OT systems are very different, right? So compliance also means different, and security controls also mean difference. So that is why 62443 has been built to ensure that IAC or industrial automation control systems are secured in the meaning of it, right? Considering from what level, what threat, and what kind of security is required for that particular system. Why? Because we are facing a lot of threats in the near term, right? So we can see that every other day we can hear about ransomware attacks, about nation state actors, and insider threats. We can see spear phishing happening, that is targeting critical employees in the organization. 0 day attacks have gone on increasing. To show on the 0 day attacks, we can see this particular slide over here, right? So you can see that the number of the vulnerability reporting and all that, you can see here, it started around say 2000s. You can see that it is in the initial stages, right? So you have less than about 20,000 vulnerabilities in a year. As we have progressed, you can see the number of vulnerabilities coming out every year is just gone exponentially high, right? You can see there are three particular colors used here. So one is the vulnerabilities itself, which is in a purple violet shade. Then in blue you have weaponized exploits. So that means these exploits are the ones which are being there have been exploits created for them. There's easily downloadable. You have the packages readily downloadable, and then it can be run. And these are even for the ICS systems, right? Because ICS systems typically are built not with security in mind but with operations in mind. Though it is changing, but the previous factories which were already there are all still using old and outdated technologies. The reason being that if you want to change, say an OS, that means it would mean that you're probably the application needs to be changed. The application has to be also updated. The application updated, probably you may also have to change the the entire instrumentation, the entire control system as well. So it's a big change to be made just for an OS. So in many cases these changes don't happen as well, right? So we have a lot of weak systems, plus we have a lot of exploits readily available. I was talking about 0 days previously, and if you can see at the bottom, there's a light blue, and you can see that the number of 0 days have gone on increasing uh, with every year. So that means there is no patch available, and the vulnerability has been used tremendously out there. So that means even the IT systems are not secure completely, which are supposed to be built on, a secure, and having all the patches in place, may not be secure enough, right? So from that perspective, we can see that in today's world, where we have a lot of vulnerabilities, a lot of threat actors, and increasing threat action which is going on, and we are sitting with industrial systems which are the prime targets for many, because of the nature, because of the impact it can cause, because of the disruptions it can cause to a community, to a country, to a person, and to the money that can be gained out of it. Now, say we talked about spear phishing, we talked about all these things, ransomware. Now, what will somebody get out of stealing this information, stealing that money? Maybe everybody who is trying to get this information from your IT systems, from your corporate infrastructure and all these things, is not maybe trying to harm you directly, right? So he's trying to make money out of this at the end of the day. So what will we do with all these breached accounts, with all these collateral information that he has available with him? Basically, they sell it on the darknet, which is basically your Tor network, which is over there, which has got basically three relays and an entry node and exit node built for the purpose of anonymity, but has been used as a place for as an illegal market, right? You may be surprised to know that, say, maybe you have now ransomware as a service, you have infection on demand, you have remote access trojan, you have malware as a service, and all these things, and they are available at very cheap prices. So if somebody is targeting you, then it can be done at a very less cost as well in today's world. So thereby is the importance of protecting our fort, right? So this is just to symbolize where our criticality lies. So what is important to us is to be put in the center of the fort, and the fort has to be strengthened. Like in this fort, we can see there are a lot of security controls with a moat representing your DMZ, with your security guards representing your IPS and firewall, with your perimeter security wall, which is there, and access control with watchman, which monitoring from the top, and cannons also. So there is a lot of controls and designs which has been shown, which has been tried to be shown as a part of this image, right? But how do we actually get there, from this image in actual cybersecurity perspective? The answer is defense in depth. We know already that systems are weak. We cannot patch these systems, even if we know that a patch is available. Sometimes we cannot upgrade these systems, even though the systems, we know that if we upgrade it, they'll gain some sort of security from that aspect. But we may not be able to do that because of the nature of the system, because of the proprietary protocols, because of the proprietary connectivity, because of the operations may get hampered because of lack of, or too much of control. So availability is the key in industrial control systems, and hence we may not be able to put many tight controls as well. So then how can we secure these systems? Basically, defense in depth, having various layers of controls, and having these controls in such a way that they are stacked one on top of each other to ensure that our systems are secure, right? So even if one there are holes in one system, the other system should take care. Even if there's a hole in two or three systems, it's okay, so we can manage. So how do we make this different multi-layered wall, like you can see layers of an onion? How can you do that, and how do we know what is the right thing? Should it be the same control for everything? All your assets, do they need exactly same type of controls? Do they need different type of controls? What do they need? How do we get to that? If you want to get to that, you need to look at the standards for that. So you have 62443, which gives you direction in this case, and it provides three sets of directions in with 13 standards, right? So IC 62443 2-1 provides about the cybersecurity program which can be done. 3-2 provides the methodology for risk assessment. 3-3 provides the security controls that may need to be implemented. Now, this I'm talking from the perspective of a say an asset owner, from an operator, somebody who is running the factory, an end user, not necessarily from the perspective of the component manufacturers. For them, we have different standards, as in 4-1 and 4-2, right? So these standards will provide the direction as to how and what controls, where the controls are needed, how much control is needed. If we just follow these standards in its essence, by implementing the technologies, by implementing the standards, by implementing the processes which are mentioned here, we should be in a position to reasonably get to a place where the controls and the amount of controls required for each particular zones have been well defined, and we'll get to that by the end of this session as to how to get there, right? So it's a long prologue that has already happened, right? So now we are up to the core topic over here, no? How to identify what controls, how much controls, the level of controls that we require. For that, we need to do a risk assessment, right? Now, what is a risk? A risk is typically a chance that something can go bad, right? I'm driving from my home to the office, the tire could burst, right? So that is a risk. It depends upon what are the threats involved in that. It could be the tire is, the road is uneven, somebody has put a nail, there was an accident on the road previously, so there are a lot of threats on the road, right? And the vulnerabilities are basically improperly maintained tires, or maybe improper driving. All these things are vulnerabilities. So I just give an example of a risk and threats and vulnerabilities associated with that. So risk in cybersecurity terms, we try to put it in the context of a product of threat and vulnerability. It's a chance of something bad happening. A chance is a likelihood, and bad is a consequence of if that threat is materialized or if that risk is materialized, right? So now I will refer to four key terms here before I get into the actual slide which explains the process that we use. Zone is a concept which we use in 62443 for clubbing various devices which are maybe functionally same or operationally same or physically in the same location, depending upon however we are trying to define that zone as zone, right? Now all the devices in the zone are considered a part of one entity. A conduit is something which connects between two zones, right? So there may be a zone A and a zone B and a zone C. Now there may be connections between zone A and zone B, multiple connections, and zone C. So zone A and zone B may be trusted, untrusted, semi-trusted, depending upon that. So how much control is required for zone A, how much control is required for zone B, and how much control is required for zone C is based on the criticality of these devices and where it is placed. And that takes that how much control is defined by the security levels. The overall this whole setup is called the system under consideration, which includes the entirety of your scope of your risk assessment or your industrial control systems, right? So now I was talking about security levels. There is currently there is a lot of discussion happening on this SL levels, SL1, SL2, SL3, SL4. So SL1 is basically prevention against casual coincidental violations. SL2 is basically with low resources, generic skills, and low motivation. So basically based on the threat actor. Now, for some, this does not work because it says you're only measuring these security levels based on the threat actors, not necessarily based on the risk to the system. But I'll show why this works in some time. Okay, and you have a target security level which is based on your risk assessment. You have an achieved security level based on your systems that you have already implemented, and capability. Your devices have a security level capability. So the SL4 is the most secure, or the most, or the system which requires more control when we say in terms of the target. SLA is what we have already achieved, right? And SLC is the capability of these devices. So SL1 is the lowest and SL4 is the highest. So we were discussing on the risk, and I'll come back to that. So risk, we mentioned, is a product of threat and vulnerability, right? So if there is no threat, then there is no risk in this scenario, right? There is no risk. For example, so now you have a house in a desert, somewhere far away from humanity. There's nobody there, so you don't need to have walls. There's no vulnerability. I mean, there is no threat there. You are fully vulnerable, but there is no threat, right? In the same way, if there is no vulnerability, you are in an iron dome. How many amount of threat comes, it's okay for you, right? So that is the risk. Now the same thing, now this is whether risk is there or not. Now say if I want to rate the risk, I need to measure impact and likelihood. Now how do we do that? I'll just take some examples for that. So say suppose there is a vulnerable man who is walking on the street, and you have a boy. Okay, now this boy is no threat to the man. So this guy is no threat to the man at all. He's fully vulnerable, yes, but he's no threat to the man. So there is no risk in this transaction. But say now instead of this boy, there is a layman, right? There's somebody else who's a big man, and he's a vulnerable man. So is there a threat? Maybe he could be a threat. He is physically, capable. But is there a likelihood? Very less. What is the impact? Not that much. He's probably not even interested, right? So this is, but he may hit him. He may fall down by mistake. He may get hurt because of this guy. So casual coincidental violations, SL1, right? So that's what comes in here. Oops. Say, but the same man got a gun, right? He got a gun. Now he's not trained on using the gun, yeah, but he got this gun, and he has no skills on using the gun. So, but if he uses it, this guy is gonna get hurt, right? And if there's a chance that this guy may get hurt, very low possibility, but if it hits at the right spots, he may die. So the impact is very high, the possibility is very low, so the risk is not that great, but it has a big chance, right? So suppose now we replace this man vulnerable with, we harden, we reduce, we put him in a bulletproof vest, right? And then you see this guy with his skills will not be able to penetrate this, so the chances become very very remote, and he may not get much consequence out of this. Now say suppose if I replace this guy with a goon, okay, now he is trained, he has better guns, he has got intention, bad intention to hurt this guy. So will he hurt him through this? Very high chance, and the impact is also very high. So this is a high risk in this scenario, right? So say suppose now we further strengthen this guy, so we are putting high level of controls, LSL3 in this case. Now this guy, chances of him hitting this is very low, right? Because he's got moderate capabilities, moderate intentions, right? So he will not be able to, he may not be able to, if he hits, there is a possibility but not a very high possibility. So let's change this guy and say probably let's go with a sniper, maybe a nation state actor, or so on and so forth. If this is the scenario, what are the chances that he will hit through these small holes? It's a high probability that he will hit through these holes, right? So, or 100% probability that he'll hit through these holes. Why? Because he's heavily trained, he's got the best resources, he's got the best uh, ill intention which is possible. So he will hit, right? So let's say now change this to a fully hardened man. So he is no vulnerability. If there's no vulnerability, even this guy can't do anything. So this is how the SL1, SL2, SL3, and SL4 all together works, right? So when we're doing a risk assessment, this is the concept basically what I try to explain in terms of what are the levels, how the SLs work. But how do we define risk when we do an actual risk assessment? We can define risk through the threats which are there, the zone where the asset is placed, the asset or the asset group which we are trying to assess the risk for, then the threat actor, who's this threat actor, what is he going to do, what action he takes, the threat action, what vulnerability he is going to exploit. All these together make up your risk scenario, right? So your risk statement is actually made up of all these things. Then you go ahead and assess the other things, right? Can you do it simply? Yes, you can do it more simple way, based on risk based scenarios that you can come up with again. But it has to have a threat actor, who will take an action, and what asset he is going to take that action on, or what systems he is going to take that action on, and what vulnerabilities that he is going to exploit. So you can have that as a scenario, or that you can have that as a separate context, right? Now again, when we are assessing the risk, you can make it either quantified or qualitative. When you do a qualitative, it is subjective. When you quantify it, you can make it more real, right? So how do you quantify it? Maybe say likelihood, you can quantify it by saying that how do you access it, what is the ease of access, what is the ease of exploitability of this particular system. So that can give you to an extent the likelihood, the ease of access into the network, ease of exploitability, the vulnerability severity. All these can put together can give you a quantification for likelihood. The impact, again, you have various other metrics which you can use to measure the impact directly in terms of consequence. So ease of access and ease of exploitation. Again, to arrive at ease of access, you can define various parameters like perimeter security, network security, what controls are there. All that could be quantified, and you can have that in the place. The access levels, from where they access the network, can also be a guiding point for you. The threat actors levels which you define also play an important role, because it defines the whom are you trying to protect it against. So basically, with all this information, you will get into what you have as controls, right? You can select the controls based on the target levels. How do you get to the target levels based on the security levels. How do you get the security levels based on the risk? How do you get to the risk, security levels from the risk? So you have something called a tolerable risk, right, to which the management can absorb, right? What is the risk that management can absorb? And you have something called the current risk, okay, or unmitigated risk. So the current risk divided by the tolerable risk will give you the risk reduction factor, or the cyber risk reduction factor. From here, you can map that to your security level based on that, standards. So that's how you get to SL, right? And then from that security levels, you can go on to selecting the appropriate controls based on your 6443 standards. So whether you want to go for foundational requirements, baseline requirements, enhancements based on the SLs which are coming for that particular areas, right? So that's how we do it. Once we get to that point, you develop a cyber security requirement specification, right? So you basically, for each zone, for each assets, you make a requirement specification which gets into your program, right? So that's how, based on all these things, now when you're doing a risk assessment, if we have to identify the vulnerabilities, you do need to have an assessment or kind of understanding of what vulnerabilities are there. If you need to do a understand who are the threats, maybe you have to do threat mapping or threat modeling, right? You have to have a list of your assets, so maybe you need to have an asset verification or an asset management program in place. You need to understand your where your gaps are, so maybe a compliance assessment is required, an architectural review is required, all the company documentation is required, the network need to be split into various zones and conduits. Seems daunting, but do everything together, right? Don't start the big high detailed risk assessment together. That's a big pitfall. Try doing it in bits and pieces. Try doing it in smaller chunks, in phases. Once you do that, zone a particular area and identify what are the conduits coming into it. See, when we look at probably a network architecture in its entirety of a control system, it may look really daunting. It may look really daunting, with so many thousands, tens, thousands of IOs, and a lot of communications going across Modbus, heart, lot of communications happening all across Ethernet IP, maybe CIP in some cases. Uh, it may look really daunting, and plus the external communications, internal communications, all that. But to help you with that, you need the zone and conduit diagram will simplify that for you, so you can focus on what is communicating outside, what is communicating inside, what is going out, what is coming in, what are the protocols which are going out, is it communicating with a trusted zone, is it communicating with a non or an untrusted zone, is it a semi-trusted zone or a same level as it is. So you can basically then identify as to what are the areas that you need to focus on. So zone and conduit diagram is a really an important thing. Obviously, understanding of your infrastructure is something which is really critical. And you need to always involve, when we do a workshop, always involve the asset owners in terms of the people who handle the assets, people who understand the operations in and out of that particular system, because that is also very critical. Their understanding, their inputs are very important for this study. And you need to have somebody who is not directly affected by these risks and controls which are being put in place. So you need somebody who is a facilitator, who can help you and guide you, so that the subjective aspect does not come into place, and that will help you to come out with a good risk assessment. So the cybersecurity requirement specification will help you identify as to where the controls have to be placed, how the controls have to be placed, at which level what controls need to be placed, which zones require more control, or if you are doing a level asset based, then which assets require more control, and so on and so forth. So this will give you a clear direction as to how we can basically secure our system using IEC 62443, right? So the 3-2 will provide you the methodology as to how we can do an appropriate risk assessment. 3-3 will help you in selecting the controls required for that. 2-1, now once you have the requirement specification, 2-1 will help you build this entire into a beautiful cybersecurity management system program. So that is how ISA 62443 will help you coming out of compliance and going into actual security, because you may not need all the controls which are required for a system. For an uncritical system, you may not require all the controls which are there in the standards. Okay, and in some cases, there are certain controls which are not mentioned in the standard, because the standards basically provide something called baseline kind of controls, which needs to be implemented. They may not really be securing your systems, right? So that is why if you're just complying, you may not be securing. Even if you're meeting the intention of the compliance, you may not be securing, because you may be having big holes in the overall network, but you will be covered to a good extent if you are meeting the intention of the compliance. So that's it from me. You have three phases. The first phase, assess, which we talked here. Based on that, you will do the design and implement, and once you do that, you will do the maintain and monitor. So what we and how to design the control that, right? So that's it from me. Thank you so much. If you have any requirements, any queries, please feel free to ask them. We do support in these matters. Thank you.
Thank you, Naveen. It was really informative. Now we'll move to the Q&A session. I have few questions actually. Your session triggered some questions, which is very interesting questions. I can see here one from Aravindan from YouTube. So he's saying, Naveen, what is your message to the CXO who are doing cost benefit analysis to switch to the state of the art secure system from an existing ICS originally built with just availability in mind?
Who are doing a cost benefit analysis to switch to a state of art security systems.
Yeah.
If it's a greenfield project, probably you can switch directly to a state of art system. If it's a brownfield existing facility, it's really difficult to move directly to a state of art security system. And what you can do is, like I discussed, you can add layers, you can add multiple layers which are and maybe state of art, right? You can have the network monitoring, you can have EDRs, and so on and so forth, which are there. But can you really block the operations with these things? Doubtful. But you can definitely add additional controls which are there in place. You can improve it to a level where you can be confident that there is no chance of a breach, right? Which is the most important thing. The requirement is not to be state of art. The requirement is not to be the most modern. The requirement is to be secure, right? And security may not come with complete transformation. That security will come with the transformation of the culture, with the understanding of the system and the controls which are required to protect that, right? So
And a
that
fit
is that
for
is more
use.
important.
Exactly, and a fit for use for that organization. Yeah, and, we don't need. We are usually in cybersecurity and OT cybersecurity. We are not calling for a gold plating. We are just
Yes.
looking into implementing security to the level required or to the organization risk appetite.
Correct.
Okay. So the second questions from Mr. Muhammad Atif from LinkedIn, Babar. I think he was referring to the slide with the castle and the blue water. He's saying if the blue color represent the vulnerability in IT side, especially operating system and its compatibility with ICS, industrial control system application, how we can say that these vulnerabilities are affiliated with ICS.
Okay, I think the most of your SCADAs, most of your control systems, so all run on top of these OSs, on top of these systems. Now, it was much earlier that the vulnerabilities of control systems were not being identified. Now the vulnerabilities of control systems, Rockwell, Siemens, whatever you
Mm,
take it, they are all being identified. Now I think what you're referring to was in the slide where I showed the exponential rise of
mm,
vulnerabilities, right? So that is where that is where the slide has come in, or the question has come in. So in that, yes, the blue is maybe the light blue which you're talking about, probably is the 0 days. Now the 0 days will impact the OSS, will impact. Correct. What you're saying is right, but will it impact your ICS if not adequately segregated, if not adequately configured, if there is direct links onto your system? Definitely it will impact,
yeah,
100% will impact. So how can we be sure? Do a risk
mm.
assessment, check. You can be sure then, and that you are not
Excellent.
affected. If it's not affected, it's great.
That takes me to Muhammad Atif's second question. Actually, he is asking, can you please give a practical example of risk assessment in industrial control system? Because maybe the way you explain it with the boy, the man, the sniper. So, can you give just a sample risk assessment similar to the one you just mentioned now?
Right. So, say for example, you have. I mean, you can do it in multiple ways. You define the asset you want to consider, the zone in which the asset is. Say, suppose the asset is in a control
Mm,
zone, right? And you look at the asset that you're talking about, maybe an engineering workstation or maybe some other workstation that you're talking about. Who is the threat actor that you're talking about? Is it a contractor that you're talking about who is there in house, or is it a remote access that you're talking about? If it is a remote access, then what is the level of access? Is he coming in from internet? Is he coming from level 4? Is he coming from level 5? Then you define the nature of that guy. What is the nature of this guy? Is he nation state? Is that what you're thinking on? Or is he a hacker? Maybe he was just learning his ropes, right? You define those things. Then what is his action? So you define a threat actor. Now what is his action? Is he trying to implement or run some program on your system? Is he trying to exploit something on your system, or is he trying to say probably collect data from your system? What is he trying to do? Define that particular action, right? Once you define those actions, then you say, okay, if he has to do this, what are the vulnerabilities that he needs to exploit, right? Then you put those. So now you have your risk
mm,
statement. So you have your actor, you have the action, you have the asset, you have the vulnerability that is going to exploit. Now look at what the consequences of that, right? You put what all can happen, what are the consequences that can happen of that asset. If that service goes down, then what is the action, right? What are the things that can happen, right? Then you rate it. To rate it, then you look at, you can either do it subjectively, qualitatively, or do it quantitatively. If you want to do it
mm.
quantitatively, you go for ease of access, ease of exploitability, vulnerability severity, a lot of things. So this topic is actually something which can be discussed for
Exactly,
days and
exactly.
explained. But
So I think that maybe we'll need a dedicated session just for risk assessment because even as you know, it's in the ISA 62448 they have a dedicated standard for it. It's not something like we can
yes,
just
see that.
discuss it over. A quick question. So let me take you to the second question. Moving to the controls. Aravind he asked about. I've seen some companies look at unified cybersecurity management systems for IT and OT. So, do you see this positive trend that complement security, or would you advise to keep them separate?
See, a unified framework is something which is good. A unified framework is good. Unified policy is good, but not necessarily the controls which can be unified. So the nature of the controls, the characterization of the controls cannot be unified, right? By nature, that's what we try to define
Mm.
here. The cybersecurity requirement specifications. Basically, we are not even putting the same level of controls for each set of systems. We are putting different controls based on the characterization of that particular system, right? So there is no question of it being harmonized in those terms, but these two need to work together. If they don't work together, or if they are not complementing each other, as mentioned by Mr. Arvindan, is a disaster, because they have to complement each other.
Exactly, and I'm really one.
So unified system is
I'm
good.
also from that side who really look into this in more positively. I don't like to have a shadow IT or duplicated. However, when we talk about OT or IT to OT or OT to IT convergence, we need to understand that that convergence mean not using all the tools from IT to OT, but picking the one which is suitable
Absolutely.
for OT. That's the convergence what we need. If something that fit
Absolutely.
the purpose, it's not impacting our industrial control systems and the operation and the safety above all, then that can be used and can be shared, can be used as a shared tool between the IT and OT. However, if there is a well-known impact, definitely that's a big no. Yeah. Moving to, yeah,
True.
thank you. So moving to Muhammad again. Muhammad was asking about how can we quantify the threat and 0 days vulnerabilities. Is that a way we can quantify it in a way that will help us maybe in a risk assessment?
Yes, absolutely. See, quantification. There are two things that we are quantifying in this. We are quantifying the impact, and we are quantifying the likelihood. Right. These are the two things that we are trying to
Mm.
quantify. We are not necessarily trying to quantify the threats and vulnerabilities. Based on these threats, vulnerabilities, characterization of the asset, we are trying to quantify what is the impact and likelihood. Why are we trying to do that? To not to get a subjective analysis or a qualitative analysis of the risk, depending upon the amount of time you are ready to spend on this exercise. Because remember that each exercise will take time, so the amount of time you spend is equal to the quality of the report at the end of the day, right? So if you go on an endeavor to do the quantification is on the impact, and the quantification is the likelihood. Now for likelihood, you have two parameters you can quantify it based on: ease of access and ease of exploitability, right? So the ease of access portion is depending upon your level of access, the threat, right? The amount of various other existing controls that you have already put in place. The ease of exploit depends upon your vulnerabilities. For a 0 day, ease of exploit is like 100%, right? Because it's not even know, you don't even have a control to that, right? It's 100%. People know it, that's why they have come to use it. So you can quantify it based on that, definitely, yes.
Okay. There was a follow-up also from Muhammad Atif. I'll just show it. I think maybe it's not clear. If the controls are implemented properly, how device can communicate across zones.
Okay, see, the controls does not mean that you block
Exactly.
communications. The control is for strengthening the communications, not to block things. The entire purpose of cybersecurity is not to stop anything. Cybersecurity is an enabler. It is the purpose of cybersecurity is to ensure that business runs smoothly. If cybersecurity is blocking the business, it is better to throw it away, right? There's no purpose, because at the end of the day, the business makes the money, right? So cybersecurity is supposed to enable, and we can enable it very effectively, and ensure that all controls are implemented without blocking any required
Yes.
communications, right? So when we're
Yes.
talking about
Go
these
ahead.
one topic, let me put in firewalls. When we are talking, the base principle that we use is deny by default and allow by exception.
Mhm.
So you have your allow what is required by exception.
Ganesh, I think he asked very good question. This is, I think, most of our OT team, they are asking the same thing. We are requested to identify the risk reduction factor, and how we can link the risk reduction factor to target security level. And is there any best practice that will help us to derive that?
See, it depends upon your risk matrix, right?
Mm,
So you, if you use a 5 by 5 risk matrix, the percent the ratio will change when you use a CRRF to an SLT. When you're using a 6 by 6 matrix, the ratio will again change, and when you're using a 3 by 4 or some other matrix, the ratios will change.
mm,
Now, what I use is I use mapping methodology for CRRF to SLT, which was shown to me during one of the initial ISA 62443-2 training sessions. And we use that. Probably we can discuss more on this topic. I can elaborate. How what are the different for different matrix, what kind of ratios you should use, and what is more advisable,
excellent.
right? So
Yeah.
we can do that maybe some other day.
So, Muhammad, for regarding to your question, Muhammad Atif Babar, I think maybe you can refer to ISA 62443-2-1. That will really help you a lot in understanding the cybersecurity management system and what type of information is required, just to save some time. And maybe you can move to Hiren. Hiren, welcome. You are very active in following up ISA Oman and the topics. Your question is regarding what are the current challenges to IT/OT convergence. So, Naveen.
What are the current challenges? See, one is there's a need for business integration, which is a prime business driver. There is a lot of reluctance from the operations because there is a threat of attack. There is also a lack of security culture in terms of the organizations, though people are aware of these things nowadays, but on a broad level, the small disciplines and practices are not in place.
Okay.
Now, these are the main challenges. The other technology challenges are, though it may seem as the major challenges, are not actually quite challenging enough,
Hmm.
right? They all have appropriate technical solutions for those things, appropriate planning and architecture, those convergence related issues, right? But what is important is understanding how this needs to be done, right?
Hmm.
Understanding the convergence in its entirety, not as a piece by piece thing. It has to be understood as a whole, right? And then what is needed needs to be sent out. Second, you have the AI which is coming now, and you have the cloud which is also rampant. Both have not been addressed by your any of your standards in 62443, or say any of your OT standards does not address these two things. And there is widespread adoption of this, both cloud and AI. And while they are very effective, very helpful, they are also have their own risk which needs to be assessed in its own way, right? So I think by the time those come into standards, we'll be again sitting with a bunch of old legacy systems.
So, so I
The
just my
challenges in my mind.
5 cents
So
in here is really one of the challenges that also I can see is the culture of that organization. Each organization culture differ, and also the management buy-in. So if the management themselves they are not really in that mode of having that IT/OT convergence, regardless of how beneficial it is or how risky it is to that industry, they will not really seeing it happen. You will not see it happen. So if the management are really buying it and they see the value, then definitely they will support it. Most of these strategies, long-term strategies, they need to come from top down, with of course proper management of change and communication to all respective stakeholders as well.
see, but IT/OT
The last
convergence
question.
is a requirement of the management, right? Because they want the data from OT, right? That is the business drive. So they will be pushing for it mostly.
Indeed, but you will still sometime find few of these top management internally within the CXO having that misalignment. So if that initial misalignment is not really ironed out, then you will still face these challenges.
True.
The last question by again Hiron, specific to both running aging asset with legacy system and for new greenfield project as well. Maybe he was. This is just a comment. Maybe he was following up on another things. Yeah. Okay. Uh, I think that's it. We'll be closing. So again, let me just open this. Okay, so Naveen, on behalf of ISA Oman section, I would like really sincerely to thank you for delivering such an insightful and impactful session on beyond compliance, transforming OT security through ISA IEC 62443 standard. Your perspective on shifting from checkbox compliance to building truly resilience and secure OT environment has provided tremendous value to all of us, especially as a cyber risk continue to evolve across critical infrastructure and industrial sector. We truly appreciate your time, expertise, and practical insights. Thank you very much, Naveen.
Thank you.
Okay, so before we close, I would like really to encourage all of the attendees to register as member of International Society of Automation (ISA) and become part of ISA Oman section. ISA membership gives you access to international standards such as 62443, the one we've just discussed and went through. Also, a world-class automation and OT cybersecurity resources, technical publication, tools and trainings, professional certification, webinars, workshop, global networking opportunities, and a strong professional community supporting both OT and automation professionals. Whether you work in engineering, cybersecurity, automation, or industrial operation, ISA provides the tools and knowledge to elevate your career and strengthen your organization. Thank you once again to our speaker, and thank you all for your active participation. We look forward to welcoming you in our upcoming ISA Oman Knowledge Connect session. Have a great day and stay safe. Assalamu alaikum wa rahmatullahi wa barakatuh.
Joining the International Society of Automation as an individual member is one of the smartest career decisions you'll ever make. ISA members have unparalleled access to technical resources and networking opportunities, delivered by a nonprofit professional association that has represented the needs and interests of automation and control professionals since 1945. ISA membership costs just $120 per year and gives you access to dozens of benefits. You can network with other professionals in your local area through ISA's geographically organized sections. You can access cutting-edge technical resources, like ISA's renowned industry standards, online web seminars on hot topics, thousands of peer-reviewed technical papers, and much more. You'll get discounts, 20% in most cases, on your purchases of ISA training, publications, and event registrations, and you'll earn 2 free technical division memberships so that you can join expert communities in the topics and industries that matter to you. Plus, joining ISA opens up a world of leadership possibilities. You could contribute technical content and get published in our magazine or e-newsletter. You could volunteer on a committee or run for an elected position on our leadership team. Or you could contribute your expertise to a standards development committee and change the way we look at technology in the future. There are so many opportunities to get involved, but it all starts with becoming a member of the greatest automation society in the world, ISA. For more details, visit www.isa.org/member benefits.